Hi peoples, so how do we calculate the rate of reaction? I'm just going to go through the one we did on the board today, but see if we can do it a bit slower in case you want to review it again. So, we want to use this graph on the left to find the reaction rate of the decomposition of methane between 3 and 7 seconds. So basically when you get questions about rate, the rate is just the change in the value, change in y over change in x. Okay? So you've got two axes here, you've got a y-axis and you've got an x-axis. Okay, so to calculate the rate, you do the change in the y over the change in the x. So, let me rub that out, because I don't have much room. Oh, I've got room over here. Let's go. So, that is also equal to y2 take y1 over t2 take t1. Or the final value for y, take the initial value for y over the final value for time, take the initial value for time. So we've got 3 and 7 seconds here, between 3 and 7 seconds. So what's our t2? Well, it's the final value for time, so it's 7 seconds. What's our t1? It's the initial value for time, it's 3 seconds, okay? So we can do the bottom bit. It's now going to be 7 take 3. Okay, seconds. Then what about the top, the change in y? Well, what's the value of y when x is 7? So we go up to y, it's a really bad line, and then across. And it's about 18. So when x is 7, y is 18. So our final value for y is 18. What's our final value? What's our value for y when x is 3? So again, we go up from 3 to this graph and then across. And it's 35. So it's 18 take 35. So that's going to give us the answer, which is negative something or other. Now, is it a problem that it's negative? Not really, because it's the reaction rate of decomposition. So it's decomposing. You expect it to be less over here than it is over here. So that's why it's a negative number, so that's fine. And the next part of the question was draw a new line on this graph to show how a temperature increase would affect the reaction progress. So if the temperature increases, what does that do to the rate of reaction? Remember, it increases the rate of reaction because it provides the molecules with more energy, and so therefore they're going to move faster and they're going to collide more. And also because when they collide, they'll have more energy. I'm in the staff room, I don't expect this to be a perfect recording. When they collide, they're going to have more energy, and so you'll have more collisions, and more collisions will possess the activation energy. So you expect the rate to be faster, so therefore this line is going to drop quicker, isn't it? Okay. Oh, now one more question. What do you think happens to the concentration of methane over this time? Well, obviously it's dropping. What happens to the concentration of the products? It's increasing. Okay, hope that helps.